welcome back. So what we're looking at today is 6.5, measured reasoning. So let's go ahead and jump right in. All right, so for this first part, we're looking at the Pythagorean theorem and ratios of similar triangles. So we want to find the missing side in each of the right triangles. Note the triangles are not drawn to scale. So remember, Pythagorean theorem is a squared plus b squared equals c squared. So the first one we're going to do together is number 1. So 3 and 4 are representing the legs of this triangle. So that means we have 3 squared plus 4 squared equals, we'll just make it x squared. So 3 squared is 9, 4 squared is 16 equals x squared. 9 plus 16 is 25. To find what x is, we take the square root. So square root of 25 is 5. So our missing side has a length of 5. All right, the next one we're going to look at is number 5. So in this case, we're missing one of the legs. So that's where the question mark is. And 9 is the other one. So we have 9 squared plus x squared equals 15 squared. So 9 squared is 81 plus x squared equals 225. Subtract the 81. So now we have x squared equals 225 minus 81 is going to give us 144. We take the square root, and so the square root of 144 is 12. So our missing side length is 12. So that's what you guys are going to do on 2, 3, 4, and 6. On number 7, you're going to look at the ratios of the sides. So remember, taking and looking at you can use the legs, you can use the hypotenuse. It's probably easiest using the legs. Looking at comparing them. So 9 and 12, 4 and whatever this might be. Up here we had 3 and 4. Seeing if there are similar triangles. So 3 and 4, we can multiply both of those by 3 and we'll get 9 and 12. So that means triangle A, and we'll name this one E, and this one F. So triangle A is similar to triangle E because 3 over 4 equals 9 over 12. So there are other pairings. There are 2 more pairs of similar triangles, which makes sense since we have 4 triangles left. So you'll figure out those pairings as to which are similar. Remember, similar means that we can multiply all of the side lengths of one triangle by a constant value and get the other side lengths. All right, so our next section, using parallel lines and angle relationships, find missing values. In each of the diagrams, use the given information provided to find the missing lengths and angle measurements. So line M is parallel to N and O is parallel to P. So these 2 lines are parallel and these 2 lines are parallel. So we've got a transversal that's cutting through all of them. We also have both O and P can be considered transversals for M and N and vice versa. So we want to find the angles of X, Y, and Z and also find the lengths of A, B, and C. So I'm going to zoom this in so you can see a little better. All right, so first and foremost, we use what we know about all the different theorems. So alternate interior angles, same side interior angles, supplementary angles, linear pairs, complementary angles, vertical angles, all these different theorems. So theorems is your keyword for this lesson, to take and work through finding these missing parts. Such as, this angle right here is 40, which means this angle over here is also 40, which means this angle right here, the alternate interior angle, is 40. So this angle is also 40. That one's 40. Now, we found what Z was, so that was helpful. Now, let's see. If we're looking at, there's a lot of things going on here. So over here, we've got our 80 down here. So we know this right here would also be 80. And we know this would be 80 then. Just filling in anything we can to help us. So the fact that we know two angles in a triangle, we can solve for the third. So 80 plus 40 is going to give us 120, and 180 minus 120 will give us 60. So this angle right here is 60. Notice, parallel lines cut by a transversal, so 60 and y are going to be the same thing. So that means y is 60 degrees. Now, using corresponding angles, because these were corresponding angles, and now these are corresponding angles, so that means x is also going to be 60 degrees. So we've been able to find all of our angle measures. Now we need to look at the side lengths. So we have A, which is right here. We've got B, and we have C. So a lot of different parts and trying to find what each of those are. Now, if we look here, parallel lines cut by two parallel lines. If this side here is 6, what do you suppose this side is? It's also 6. So that means B is 6. Now, C's down here, and A is right here. Now, these two pieces are actually the same amount. Crazy as that may seem, but they are. So, finding the relationship between them, what we want to take and look at is the fact that we have these side values here now. We can set up the proportion for this. So 20 over, A, because we don't know what it is, equals this whole side, 9 plus 6, which is 15, over just the 9. So we cross multiply, so we've got 15a equals 20 times 9, which is 180, and 180 divided by 15 is 12. So a equals 12. Now we can set up that same proportion over here. We have the 12 and the 4, we've got the 9 and the c. We set up that proportion, we're going to find that c is also 12. So using all these theorems, postulates, different things you know about parallel lines and transversals, you're going to do the same thing for 9, okay? All right, the last section, solve equations including proportions. So solve each equation. The first one we're going to look at is number 12. So obviously we want to use cross multiplication here because we've got the fraction. So we're going to have 18x equals 3 times 5 is 15x, and 3 times 2 is 6. We subtract the 15x. 18 minus 15 is 3x equals 6. Divide by 2. Or sorry, not divide by 2. I was thinking what the answer was. Divide by 3. Sorry about that. So x equals 2. All right, the next one we're looking at is number 13. It's got fractions in it. So if we take 3/4 and we subtract 1/2 from it, what are we going to end up with? We end up with 1/4 x minus 8. Then we add the 8 over. So -7 plus 8 is going to give us 1 equals 1/4 x. So x equals 4. We multiply by 4 to both sides here to find that. All right, and the last one, 15. So once again, cross multiplication can work for this. There's other ways to do it too. You could multiply both sides by 18, and then you'd be able to take and cancel out the denominator, but cross multiplication works just fine. So x times 9 is going to give us 9x. 5 times 9 is going to give us 45, equals 6 times 3 is 18 times x plus 2. So we have 9x plus 45 equals 18x plus 36. So now we want to take and subtract. So move the 9x over. So we have 45 equals 9x plus 36. Subtract 36. So we take 45 minus 36, and we're going to get 9. So we have 9 equals 9x. Divide by 9. So x equals 1 is our solution. All right, if you guys have any questions, feel free to ask. Have a wonderful day. Bye, guys.